Section 8.2 is going to cover arithmetic sequences and partial sums. And what we want to look at is finding a pattern and finding some formulas that are going to help us simplify arithmetic sequences and series. Now, arithmetic specifically means we are going to be adding a constant to the previous term or subtracting a constant from the previous term. So here, if I look at 8 to 16, 16 to 24, 24 to 32, all these are being increased by 8. So if I wanted to find a recursive formula for that, I would say that a sub n is equal to a sub n minus 1, and all this is saying is the previous term, and I'm adding 8 to it. Since I'm adding a constant, this is an arithmetic sequence. And the difference between each term is called the common difference. So common difference is what you would add or subtract to get from one term to the next. So finding the common difference, pretty self-explanatory. You just want to figure out how far apart each of the different values are. So in the first one, we're adding 3, and the other one, we're adding a negative 4, or subtracting 4 if you want to look at it like that. The next thing we want to be able to do is we want to figure out a specific term for an arithmetic sequence. So right here you can see the pattern that emerges. Every single time we are going to add a constant d, this common difference. And as we go along each and every step, we are going to just keep on adding another d to it. So the pattern that emerges for the general term is that a sub n is equal to my starting value, a sub 1, plus n minus 1 times d. So that's my general term formula for an arithmetic sequence. What this is saying is if I know my first term and I know my common difference, I can then plug in any value to get that specific term. So if I wanted the 9th value, I would plug in n equally 9, provided I have my first term and my common difference. So under example 2, we want to find the nth term of an arithmetic sequence with a common difference of 5 and a sub 1 is equal to 9. In other words, I want to find the explicit formula or the general term formula for this sequence. That's what the nth term here means. I'm not saying find the 6th term. I just want to know the general term. So we know that a sub n is going to be the first term plus n minus 1 times the common difference. And we know that a sub 1 is 9. We know the common difference is 5. So here I can distribute the 5 in, and that leaves me with a sub n equaling 5n plus 4. So what that formula tells me is if I plug in the value of 1, I get the first term. Plug in the value of 2, I get the second term. 3 is the third term, and so forth. And I can do a quick check here by plugging in a 1. A sub 1 is 5 times 1, which is 5 plus 4 is 9, which is what we have right there. The second example, we want to find the nth term of the arithmetic sequence, but this time we're given 2 values of the sequence. We're not given the common difference, and we're not given the starting value. So we want to come up with our starting value and our common difference. And the way that we go about doing that is we go find those 2 pieces and then plug it into the general form. So first of all, step 1 is let's find our common difference. So we're going to find the common difference, which is d. And the way we do that is we're going to use the same approach that we did when we found slope. We're going to subtract our values of the sequence, and then we're going to subtract the positions of the sequence, and then divide by those 2 numbers. So d is going to be 27 minus 19. We're going to subtract our values, and then we're going to subtract the positions they are in the sequence. So I can see that if I go from a sub 5 equals 19 to a sub 9 equals 27, the common difference is going to be 2. The next thing I want to do is I want to find a sub 1. And I can use the formula up here to find a sub 1. So let's choose one of the values that we've got. And let's just choose a sub 5 since it's smaller. So a sub n we know is a sub 1 plus n minus 1 times d. And I'm going to use a sub 5, which means n is going to be 5. So we just said n was 5, and we know our common difference is 2. So here, a sub 5 we know is 19. A sub 1, here 5 minus 1 is 4 plus 2 is 8. So then a sub 1 is equal to 11. The last piece then is we're going to write in general form. And we'll take our original formula again. And I'll plug in my a sub 1, which I now know is 11. And I know my common difference, which is 2. So a sub n is going to equal 9 plus 2n. And I can do a quick check. If I plug in a 5, do I get 19? Well, 2 times 5 is 10 plus 9 is 19, so that works. If I plug in a 9, do I get 27? 2 times 9 is 18 plus 9 is 27. So yes, those formulas are correct.